So a very good morning to our madam, and in this video we're going to present our lab 5 Ohm's law. So moving to the very first part, which is the part A, right? So we're giving this link, then we're going to click into this link and we're going to construct a circuit as shown as the diagram 1. So firstly we're going to delete the original circuit, then we're going to construct this circuit, right? So we have a resistor, we have a switch, we have a supply and ammeter. So for the resistor we're going to change it to 100 ohm, and we're going to change the voltage depending on the table 1, which is here, right? We have 3, 6, 9, 12 volts. So let's take one example, which is the very first one, 3 voltage and 100 ohm for the resistance, and we're going to calculate the current intensity using the ammeter, and we're going to calculate the current intensity by theoretical, which is we're using the Ohm's law equation, which is VIR. So going to the website, right? So in this website we already construct the circuit. So on the very first one is we're going to use the 3 voltage with 100 ohms, right? So we get 30 milliamp, right? So in order to calculate theoretically is that, okay, VIR, then in order to find the current, then we need to voltage divided by resistance, then 3 divided by 100 will be 0.03 in ampere, then we convert it to milliampere, that will be 30 milliampere. So going to the table 2, we have a constant voltage of 10, 10, 10, 10, and now we're going to change the resistance, right? So same thing, after we change the resistance each time, then we will get the different value for the current, and we need to calculate the currents. So the way to calculate the current is that same things again, we take voltage divided by R, then we will get all this value here.
Okay, in this simulation, first we will set the voltage to 12 volt. Yep, and then as we can see the arrangement of the resistor as we choose before, and then after all the setup we can close the switch. So the value of the ammeter measured is 63.158 milliampere. So we can take that value into the table 3. Okay, wait. Okay, we put the value into the table, and then we have measured the current intensity I, so we can measure the 1 over I. So we just 1 over the value that we get before, and then we will get 0.016.
So moving on the question and discussion. So first question will be the relationship between voltage and I, current intensity, and the resistance with the current I intensity. So the first one will be voltage and current, right? What is the relationship? So we know that is that if there is a voltage, then there is an electrons flow, then current will be exists, right? So the higher the voltage, the more the current will flow. As the resistance and the current, the relationship, right? It will be if the resistance increase, then the current will decrease. By vice versa, as the resistance decrease, the current will increase. So for the question 2, the relationship of the theoretical value of our resistance, voltage and current, it is possible to recognize the mathematical relationship. Describe this relationship both in mathematics and written form. So we know that the relationship between voltage, current and resistance is described by the Ohm law. The equation for Ohm's law will be V equal IR. When we want to find V, then we will be calculated as V equal to I times R. Then when we want to find current, will be equal to current equal to V times R. And lastly, when we want to find the R, then it will be resistor equal to voltage divided by current.
Okay, for number 3 discussion, by using Excel, plot a graph of voltage V versus current intensity I, both for experimental and theoretical result. So for this graph, we will make the graph from the table 1 only. And as we can see, the y-axis is voltage and the x-axis is current intensity. So then we just take the value that we get from table 1 from the experimental value and the theoretical value, and then we just plot it into the graph, and we will get the experimental graph and the theoretical graph is same. So for question number 4, using your diagram, determine the values for current intensity at a voltage of 2, 5 and 7.2 V. So how we do it is from the graph that we made before, we just follow follow the y-axis, and we get 2 volt, and then we just drag the arrow vertically until reach the line graph, and then we drag the arrow downward, and we will get until reach the x-axis, and then we will get the current intensity. And for 2 volt, the current intensity is 20 mA, and so on. We do the same thing for 5 volt and 72 volt. So 5 volt, we drag the arrow vertically until the line graph, and we drag downward until reach the x-axis. Then we will get the 50 milliampere. And for 7.2 volt, we will get the current intensity is 72 milliampere. Okay, for number 5, calculate the following using the formula of Ohm's law that you have worked out. So for A, what is the resistance value of a lamp with 4 volt over 0.04 ampere printed on it? So for A, the question asks to find the resistance. So as we know, the Ohm's law formula is V is equal to IR. So when to find the R, that is resistance, the formula is R is equal to V over I. So then we just put it the value. R is equal to 4 over 0.04, and R is 100 ohm. And then question B, what voltage is applied to a 1 kilo ohm resistor when the current of 18 milliampere flows through it? So for B, the question asks to find the voltage, and the formula to find voltage is V is equal to IR. So we just put in the value, and we get V is equal to 1 kilo ohm times with 18 milliampere, and then we will get the voltage is 18 volt. And for C, question asks how high is the current intensity flowing through a resistant wire of 200 ohm when a voltage of 8 volt is applied. So the question asks to find the current. So from the formula to find the current, I is equal to V over R. So we put in the value. I is equal to 8 over 200, and I, that is current intensity, is 0.04 ampere.